This is a video lesson about electrical current and voltage. If there is any question about the content of the video, feel free to send me a message through email or Instagram. Look at this cat, isn't she cute? Imagine a cat dives into a box with packing styrofoam beans. In your house? That will be interesting to clean up. The ancient Greeks knew that static charge could be accumulated by rubbing fur on various substances such as amber, which could then attract light objects such a feather. And if they rubbed the amber for long enough, they could even get a spark to jump. This is called static electricity. The word electron came from the Greek word which means amber. Boyle determined that electric attraction and repulsion can act across a vacuum. You may remember this from Gr. 9 Science. Everything has its ability to share or hold electrons, we call that electrostatic series. When two different objects rub against each other, one object will keep more electrons than the other, as a result one will charge negatively and the other will charge positively. But what was this electricity? Benjamin Franklin argued in favor of the one-fluid theory. Benjamin Franklin thought that electricity came from groups of positively charged particles. Now we know that only electrons can move around particles. Positive charge from the nucleus couldn't move around freely. The negatively charged particles on the outside of atoms, which are the electrons, can be given enough energy to free them from their atoms. Charging by friction is when two different objects charged each other by rubbing against each other. When a negatively charged object is in contact with a neutral conductive object, some electrons will move from the charged object to the neutral object. As a result, both objects will be charged negatively. This is called charging by contact. Imagine the charging rod as a full class of kindergarten kids and the contact represents the opening of the classroom door. Once the door is opened, many of the kids will run out of the classroom. To quantify the charge, we use the simply capital Q to represent it. Q is the amount of charge, in a unit of coulombs. One electron has a very small negative charge, with an amount of 1.602 times 10 to the negative 19 coulombs. We measure the rate at which charge that is moving or flowing past a certain point, as electrical current. Current has a symbol capital I in unit of ampere, or amps. Since current is the rate of flow of charges, we can come up with an equation as you can see here. Current is charge per change of time. I equals Q over T. A lamp uses a 7W bulb that draws 0.060 of current. How much charge passes through this bulb in 8.0 hours? We know the current from the question, and we know the operating time for the light bulb. Charge equals current multiplies by time. Make sure you know that time is in seconds. So Q multiplies by time in second is 1.7 times 10 to the power of 3 coulombs. Electrons can be induced to flow by a battery, which will force electrons in a single direction, from the negative terminal to the positive terminal. This single direction flow is direct current, or DC. Electrons can also be induced to flow by an electrical generator, which will force electrons in alternating directions. The direction of the electrons changes 120 times a second. This alternating direction flow is alternating current, or AC. Your house circuit, whatever you plug into the wall socket, has to be AC current. The reason is that AC can carry electrical energy for a much further distance than DC can. Speaking about AC versus DC, it is interesting to know that these two electricity delivery methods came from two scientists, Tesla and Edison. The decisive battle took place in 1893 at the Chicago World's Fair. On one side, the celebrated inventor Thomas Edison. On the other, his former employee Nikola Tesla. In the late 19th century, Nikola Tesla defeated Thomas Edison in the AC-DC battle of electric current. If you want to know more, just Google Tesla versus Edison. Just a reminder that direction of electrical current is from positive to negative, but direction of electron flow is from negative to positive. In either case, the electrons flow because they are given energy, measured in joules, by the battery or generator. The energy per unit charge is called the potential difference, or voltage. Voltage equals how much energy per charge, E over Q. What amount of energy does it take to move a charge of 2.0 millicoulombs across a potential difference of 1.5 volts? We know the voltage, we know the charge, and energy equals voltage times charge.